Okay, we're back, and now we want to talk about non-proportional relationships. Some linear equations can represent a non-proportional relationship. If the ratio of the value of x to the value of y is different for selected orders pairs that are on the line, the equation is non-proportional and the graph will not pass through the origin 0, 0. So here's an example. This has a linear relationship, this graph right here, but it is non-proportional because it doesn't pass through 0, 0. Actually, the y-intercept is up here at 6. So write an equation in function notation for the graph. So one of the things we can do is make a table of values from the graph. So we picked off these 4 points right here, 1, 9, 2, 12, 3, 15, and 4, 18. So we find the difference between the x and y values. So as the x values go up by 1, the y values go up by 3. That suggests that the k value, if this was a proportional relationship, or the slope is 3. So we can think, well, if this was a proportional relationship, the equation will be y equals 3x or f of x equals 3x. But we know that's not true because if we check out some points, if we plug in 1, we should get 9. But if we plug in 1, we just get 3. So let's see a couple other values and see if we can determine a pattern. If you plug in 1, the value of 3x is 3, but the actual answer is 9. If you plug in 2, 3 times that will give you 6, but the actual answer is 12. If you plug in 3, you get 9, but the actual answer should be 15. You get what I'm saying? I'm just using the 3x to try to determine a pattern of how to get the real equation that represents this situation. So if you notice, the y value is always 6 more than 3x. Like 3x here is 3, 6, 9, 12, but the actual y value is 6 more than 3, 9, 6 more than 6, 12, 6 more than 9, 15, 6 more than 12, 18, and so forth and so on. So that pattern shows that 6 should be added to one side of the equation, to the 3x, so therefore y equals 3x plus 6. In function notation, it would be f of x equals 3x plus 6. Pretty cool stuff, huh? Yep. So this relationship is non-proportional. It's still linear, it's still a line, it's just non-proportional because it doesn't pass through the origin or doesn't contain the point 0, 0. All right, here's one for you to try. Go ahead and pause the video and hit play when you're ready. Okay, we're back. So I will say that A is a different problem than B. Okay, so let's do A first. Let me clear that off there. So for part A, I want to write an equation function notation for the relation shown in the table. So as the x values go up by 1, the y values go down by 1. So that suggests that y equals negative 1x. But if I make a table of those values, so let's do x, negative 1x, and the actual y value. So if x is 1, 2, 3, 4, negative 1x would be negative 1, negative 2, negative 3, negative 4, but the actual y value is 3, 2, 1, 0. So if I make the table here. So look at this. Negative 1x gives me these values, but the actual y value is always 4 more than those. Okay, so like negative 1 plus 4 would give you 3. Negative 2 plus 4 would give you 1. Negative 3 plus 4 would give you 1. And negative 4 plus 4 would give you 0. So the equation would be y equals negative 1x plus 4. Or in function notation, and it's important that you know how to write things in function notation, would be negative 1, f of x equals negative 1x plus 4. Okay? Cool. All right, let's do B. B, it is non-proportional because even though it's a line, it doesn't pass through the origin right here. So let's make a table of values. So if x and y. If x is 0, y is negative 1, 2, 3, 4. If x is 1, it's negative 2. If x is 2, it's 0. If x is 3, it goes to 2. So each time the x value goes up by 1, the y value, now be careful, it goes up by 2. So that suggests that the function has something to do with y equals 2x, because 2 over 1 would be 2, and that's the constant of proportionality if it was proportion. But notice it doesn't go through the origin, so I know I have to add or subtract something to it. So let me make a new table of values with x, 2x, and the actual y value. And once we start doing this, then we can see a pattern. Use the same x values, but 2x would give me 0 here, 2, 4, 6, but the actual y value is negative 4, negative 2, 0, 2. And hopefully from this, you can see that the y value is always 4 less than what 2x gives me. Okay, so I need to subtract 4 from the 2x. So in function notation, it would be f of x equals 2x minus 4. Okay, now look, if you notice, this graph here is similar to the graph of y equals 2x or f of x equals 2x, which would pass through the origin. It's like it's shifted down like they just took the graph and shifted it down 4 units. Okay, you see how it passes through the y-axis here. The y-intercept is negative 4. Okay, that's another way to kind of check your answer. Now we can actually check our answer using the equation. If I plug in 0, 2 times 0 is negative 4. Boom. Or 2 times 0 is 0 minus 4 is negative 4. If I plug in 3, I should get 2. 2 times 3 is 6, minus 4 is 2. Okie doke. All right, guys, hope that was helpful to you. Hope you were able to understand everything we did there. Go ahead and move on to your assignment now. Reach out to me if you have any questions. Take care, and as always, make it a great day.